Last time, we looked at how Ampere's law shows us which direction the magnetic fields point in the different sections of our circuit. Now let's look at what force this magnetic field exerts on its own circuit. Right? We already know that, Newton's laws, it's not going to move the circuit around. You can't move yourself. It takes something outside. But that doesn't mean there can't be internal forces as long as those forces ultimately are balanced, right? So let's look at it. So again, we have the same circuit. The current is flowing round and round, right? We know that due to this piece, again, I stick my thumb, and if I look at what's happening to the bottom here, right? Let's look at what magnetic field this bottom section is in due to these three sides. So if I look, I curl my fingers around, and this creates a magnetic field going into the page. Let me draw some X's. Into the page here due to this top wire. Similarly, this side wire creates one going into the page, and this wire here creates one going into the page. Where this section of wire is, we have a bunch of magnetic field going into the page. Remember, X's represent going into page this way, right? And so we have a current that's flowing this direction in a magnetic field going this way, in towards the page. So let's see if I can do this. I have my finger, right? I got contort. Right, let's go. Oh, I got to contort. It's flowing this way. This is my magnetic field. It goes in toward the page, right? In toward the page. And so we can see that my thumb, twist and turn, my thumb points downward, right? That means this wire experiences a downward force. That's all chicken scratch now. But this section of wire experiences a downward force. Similarly, all these three other sections are in a magnetic field that goes directly in toward the page, right? This current goes up. And again, my magnetic field, I have my current and my magnetic field, and my thumb points in the direction of the force. So I point my finger in the direction of the current, I point my middle finger in the direction of the magnetic field, and my thumb is telling me that this side here is pulled outwards to my right. Similarly, this top one that goes in, my magnetic field goes again toward the page, and my thumb will point it upward. The top part is pulled upward. And similarly, this one, again, my magnetic field's pointing in towards the page. My current's going down now. It's being pulled outward, right? So if I have a circuit, it's always being pulled outward by its own magnetic field, right? Now the top is being pulled upward just as much as the bottom is being pulled downward, so it's not going to move the thing, but it can stretch it outward, right? As long as it still stays in the same place, right? This is combining multiple right-hand rules. We have our Ampere's right-hand rule, which direction is a magnetic field point, right? We have our force rule, right? The current's going this way, my magnetic field's pointing this way, my thumb tells me which direction the force is trying to pull my object. Now, in this case, all my forces will be balanced, but that doesn't mean it won't be pulled in these directions anyway, right? So hopefully that's helpful.